This is just a tiny convection oven. And I found that quite disappointing to learn. I thought that I was going to find out what like the secret technology was that made air fryers so amazing. There's no secret. They're just tiny convection ovens. But why is this hash brown so much better than this hash brown? There's gotta be something going on here. And to get to the bottom of it, we're going to need to talk an awful lot about heat transfer. So sit back, relax, get naked, put on a hat, and enjoy the show. If you don't have an air fryer, then you probably have at least one person in your life who is trying very, very hard to make you feel bad about that fact by saying things that sound like,
in all of human history, there have been 5 major food-related innovations. Cooking, agriculture, bread, because holy frig. Sliced bread, the best thing since Betty White. And now, finally, the most recent food-related miracle in the history of the human species, the air fryer.
Is the hype justified? I mean, they are just tiny convection ovens. And whoa, I keep saying that. We need to figure out what the difference is between a convection oven and an oven. The difference between the two is which of these 2 buttons I push. But on a more serious note, what makes a traditional electric oven an electric oven is this heating element up at the top. The heating element gets hot, that heats up the air inside the oven, which heats up more air inside the oven until all of it is really, really hot, and then the hot air cooks your food. But convection ovens take it one step further. It still uses the heating element to get the air really hot, but it also uses a fan to blow the hot air around inside of the oven. And I've just been calling air fryers a tiny convection oven. So does that mean that this thing just has a heating element and a fan? Well, yeah. But for bonus points, it does this basket thing. Up here, there is a heating element and a fan. Because the compartment is so comparatively small and the fan is so comparatively big, there's just more movement of air inside of an air fryer. And like I said, for bonus points, they do this basket thing where this one's got a false floor that kind of allows for the air to blow past your food, circle around, and come back up underneath the food. And so it kind of seems like the whole goal here is more airflow inside of the machine. But how could that help? We turn fans on to cool ourselves down. Shouldn't that make the food cook less efficiently? It turns out that moving air just transfers heat more efficiently, whether it's heating something up or cooling something down. And we're going to talk about both, including how sweat helps to cool you down. Let's get into some heat transfer basics. In order for there to be heat, there needs to be stuff. And in order for there to be heat transfer, there needs to be some temperature difference within or around the stuff. And the simplest heat transfer example you can possibly imagine is taking some hotter thing and some cooler thing and putting them together. I used hotter and cooler because both of those things are complements. Thermal energy will naturally flow from the hotter thing into the cooler thing, thereby cooling itself down and warming the cooler thing up until they meet in the middle somewhere and the thermal energy just kind of has nowhere to go. When thermal energy is being transferred through close physical contact, that is called conduction. But when the thermal energy is flowing around in some wishy-washy fluid stuff, that is called convection. Simple example, we take a pot of water and put it on a typical electric burner. The pot itself is being heated up by conduction, but then the water inside of the pot is all kind of being heated up by convection. And here's the catch. Air doesn't really feel like anything, but it is a fluid, and so when air is being heated up inside of an oven, that is called convection. But why are only some ovens called convection ovens? Or why is it only called a convection oven when the fan is on? Well, this just happens to be a case of a very poorly named thing, at least in my opinion. And so I propose that we get rid of the words conventional and convection oven because these 2 words are not very descriptive of what's actually going on inside, and plus when you're quickly looking at cooking instructions, they kind of sort of look really similar. So to solve this problem, I think that we should call them both convection ovens. Please don't leave. But we'll add an extra word to each, and we'll call the windy one a forced convection oven, and we'll call the regular one a natural convection oven, because these are the actual names of the processes happening inside of each. This is unrealistic, but follow me for a second. If you have some food item inside of an oven with completely still, unmoving hot air, what's going to happen is that the hot air particles that are near the food will transfer some of the heat energy into the food, heating it up, but cooling themselves down. This creates something called a boundary layer that sort of surrounds the food and makes this cold pocket of air around it, making the heat transfer less efficient overall. But when you have a forced convection oven, so it's blowing the air around and it doesn't have a chance to stay put very long, what you can think of is air molecules near the food will still transfer some heat energy into the food, thereby cooling themselves down, but they are quickly replaced by new air particles that are just as hot as the first ones were, and so the whole process of heat transfer remains a much, much more efficient thing. And the same thing works backwards. Not like that. I mean, if you reverse the temperatures. On a hot summer day, you probably find yourself daydreaming about standing in front of an air conditioner. But if an air conditioner is not available, then a fan will do in a pinch. And there are two main reasons that a fan can work to cool you down, and one of those reasons is gross and smelly. The not so gross and smelly reason comes from the fact that typically, even on a day that we would call hot, the outside air temperature is actually lower than your internal body temperature. And I'm just giving people who live in hot climates a chance to type nuh-uh. Anyway, when the outside air temperature is lower than your internal body temperature, that temperature difference is driving thermal energy out of your body. It wants to leave you and join the rest of the universe. And as we know, air that is moving allows for this heat transfer to happen more efficiently. And if the outside air temperature is higher than your body temperature, then that is something that we like to call unhealthy. But even in these conditions, the gross and smelly option can come to your rescue, and that gross and smelly option is sweat. Sweat cools you down, and one main way that it cools you down is kind of counterintuitive. It leaves. Sweat just evaporates off of your body and flies away. But in order to evaporate, the sweat needs to absorb energy. Liquids don't just turn to gases on their own. And the energy that it uses to evaporate comes from your body, leaving you with less thermal energy than you had before, thereby cooling you down. I've been using the word thereby a lot in this video. It's just my heat transfer word. But the air gets sick of playing this game after a short while, and if the air were perfectly still, your invisible floating ghost sweat would fill it up pretty quickly and the whole process would stop. You wouldn't be able to sweat off any more heat. But with just a little bit of wind, your sweaty air will be carried off so someone else can smell it, and it's replaced with new air for you to stink up while you cool down. I feel like I'm selling wind. But again, the air can only hold so much moisture to begin with, and if it's already holding as much as it possibly can, then no amount of wind is going to help you with this evaporative cooling effect. And that's part of the reason why it's sort of an unhealthy double whammy when you have a day that's really hot and really humid at the same time. The high external temperature means that thermal energy doesn't really want to leave your body in the first place, and the high humidity means that your sweat can't evaporate to cool you down as a backup plan because it has nowhere to go. And we got on this subject by starting with air fryers somehow. From a technology standpoint, air fryers are incredibly unremarkable, but they're still very impressive because they've sort of mastered the art of forced convective heat transfer. And on the subject of heat transfer, wow, those are pretty bird sounds. Thinking about heat transfer, there is so much more that can be said about it. There's a lot that I didn't have a chance to get to in this video, and a lot more that I have to learn about heat transfer, and I'm thinking that that's what my next video is going to be. And so if you want to check that one out whenever it's uploaded, I won't be offended. Maybe I'll see you there. That's all that I had for this video. Thank you so very much for watching. Hope you have a wonderful day.